Welcome, class. So I don't remember where I'm at with my numbering. I think I've messed up at some point, but this is still in the vein of polynomial division. So I'm going to call this lesson 2.3 part 3. We have part 1, which is dividing polynomials, part 2, which was the rational root theorem, and then part 3, which is now talking about multiplicity of roots. So multiplicity is actually pretty simple. We're just going to do some examples of, this is mostly going to be an example heavy video where I do a bunch of long division and completely factor and find the roots of polynomials. What is multiplicity? Multiplicity is just the number of times that factor appears in the complete factorization of the polynomial. So you can imagine if you have a polynomial like x plus 1 cubed, then when you expand it all out, you get this one long thing. It only has one zero though, but that zero repeats itself a bunch of times, right? So if your polynomial was something like, x plus 1 cubed, then you'd have a 0 at -1. So -1 is a 0. And since it shows up 3 times in the factorization, then it's got multiplicity 3. And I'll abbreviate multiplicity like that, MUL period. So we'll say it's a 0 with multiplicity 3. That's a W slash. So here's an example of a factored out polynomial. X cubed times x minus 1 quantity squared times x plus 3. It has 3 roots, 3 zeros. 0 is a 0, 1 is a 0, and -3 is a 0. But you would say it has 6 roots if you count multiplicities. So what are those roots? Well, you have 0, 0, and 0. 0 has a multiplicity of 3. 1 and 1, because we have 2 factors of x minus 1. So it's got a multiplicity of 2. We have 3 factors of x. So 0 has a multiplicity of 3, and -3 has a multiplicity of 1 because there's no power up here, so you can assume it's raised to the first power. Okay, so that tells us what the multiplicities of each of those zeros are. Now we have to get the polynomial fully factored out the way we have it written there. In order to count these multiplicities, it's not enough to just see if the number is 0. You see if it makes the polynomial 0, you have to actually factor it out and then count how many times that factor appears to get the multiplicity right. Okay, so let's go ahead and do some examples. Determine the zeros of this polynomial counting the multiplicity. Our polynomial is x to the 4th plus 2x cubed minus 3x squared minus, 4x plus 4. So to go about this, we're first going to list out all the possible rational zeros. So the list of rational zeros, we're looking at factors of 4 over factors of 1. So, whoops, I shouldn't have circled the equals sign. I meant to circle the hidden 1 that's right there. So in this case, the leading coefficient is 1. This makes our life a little bit easier. We don't have any fractional zeros, we just have integer zeros out of the rational set. 1, -1, 2, -2, and 4, -4. After some guess and check, we can try, if we plug 1 in, we find that that ends up being a 0. So 1 plus 2 minus 3 minus 4 plus 4 ends up equaling 0. And so we'll do long division. And we're going to long divide out that polynomial by x minus 1. And let's go ahead and do that just for the practice of it. So our long division is set up, x to the 4th plus 2x cubed minus 3x squared minus 4x plus 4. And we're dividing it by x minus 1. Okay, so we're going to have x cubed on the top and x to the 4th minus x cubed, take that away, and we get 2x cubed minus -x cubed, so this is 3x cubed. X times 3x squared is going to get you 3x cubed. And we take that away, so we have 3x cubed minus 3x squared. Take that away. Negative 3x squared minus negative 3x squared is 0. So we have 0x squared. I'm not going to write anything. X goes into negative 4x, negative 4 times. So then we have minus 4x plus 4 minus that, 0. Remainder. Okay, so that tells us that p equals x cubed plus 3x squared minus 4 times x minus 1. Right here. X cubed plus 3x squared minus 4 times x minus 1 is equal to that fourth degree polynomial we started with. We're getting simpler. Now we have a degree 3 to work with. So we're going to look at what's left. X cubed plus 3x squared minus 4. Now this doesn't factor with your typical techniques, but you can test roots again. It's got the same set of rational zeros, 1, 2, and 4, plus or minus. We test 1 and we get 0. So that means that x minus 1 is another factor. So we've got x minus 1 showing up twice now. Okay, so we're going to long divide x minus 1 from the cubic that's left. So we'll long divide x cubed plus 3x squared minus 4 by x minus 1. Let's go ahead and do that again. So I'll do it in another color to keep things separate. So we're long dividing. First one I was long dividing, that's in red. So in green, now we're doing x cubed plus 3x squared plus 0x minus 4 divided by x minus 1. So we have x squared, x cubed minus x squared, 3 minus negative 1, that's positive 4, x squared, and so we're going to have a 4x plus 4x. X times 4x is 4x squared, negative 1 times 4x is minus 4x, have 0 minus negative 4x, that's positive 4x, and so then x goes into 4x positive 4 times. We're going to have 4x minus 4, take that away, and we get 0. Remainder. And so that tells us then that this x cubed, this guy right here, is in fact equal to x minus 1 times x squared plus 4x plus 4. So we're going to rewrite it. We have x minus 1 from the first time we factored out x minus 1. And then we have x minus 1 again from this next time we factored out x minus 1. And then we have x squared plus 4x plus 4 left. Now we're at a quadratic, and we can factor that quadratic using our factoring techniques. We can see that's x plus 2. Use another color. We can see this is x plus 2 times x. And so we've got x minus 1 times x minus 1 times x plus 2 times x plus 2. So it's x minus 1 squared times x plus 2 squared. So at this point, now we've identified what our zeros are. We've got a root at positive 1 and a root at negative 2. And those both have multiplicity 2. So x equals 1 is a root with multiplicity 2, and x equals, it should be minus 2. Minus 2 is a root with multiplicity 2 as well. Okay? So in this case, it was a little hairy. We had to long divide twice because when we got to our cubic, it didn't factor nicely. But we just, worked through the long division, tested it out, and found our answer. Okay, we're going to do it. We're going to do 2 more examples. Determine the zeros of p, counting multiplicity. So this is x cubed plus 6x squared plus 12x plus 8. So first, again, we'll list the possible rational zeros. 1, negative 1, 2, negative 2, 4, negative 4, and 8, and negative 8. We're going to try 1, that doesn't work. We're going to try negative 1, that doesn't work either. So we're going to try 2, that doesn't work. Now, I just want to be very clear, since we're adding a bunch of these things together, none of the positive potential zeros are going to work because when you're adding a bunch of positive numbers together, you're not going to get 0. It's just not going to happen. So it has to be a negative. So you can test the negative ones and save yourself a little bit of time. Turns out negative 2, it's going to give you 0 because that's negative 8 plus 24 minus 24 plus 8, and that's 0. So that means we got a long divide. So we'll long divide the polynomial by x plus 2. So we have x cubed plus 6x squared plus 12x plus 8, and we'll long divide it by x plus 2. And so x goes in, we're going to do x squared, and that's x cubed plus 2x squared. Take that away. 6x squared minus 2x squared, this is 4x squared. X goes into that, 4x times 4x squared at 8x. Subtract that off. 12x minus 8x is 4x. X goes into 4x plus 4 times 4x plus 8. Remainder 0. Excellent. That's what we want. And so that gets us, the original polynomial is x plus 2. That factor we divided out. And then what's left, x squared plus 4x plus 4, is our quotient. Okay? And now we factor that quadratic. And lo and behold, it's x plus 2 times x plus 2 times x plus 2. So this is a repeated root. We have 3 factors of x plus 2. And so that tells us negative 2 is a root with multiplicity 3. So I hope that you make a little bit of a connection. This is a bit of an aside. So this is our answer. We're done. But this polynomial right here, x cubed plus x squared, 6x squared plus 12x plus 8, equals x plus 2 cubed. Let me use another color. Really highlight this. Yellow. So x plus 2 quantity cubed is this whole thing up here. X cubed plus 6x squared plus 12x plus 8. Okay? A lot of students are tempted to just do this. X plus 2 cubed is x cubed plus 8. But that's very much not the case. That's not equal, right? We just factored this x cubed plus 6x squared plus 12x plus 8 polynomial out, and it is x plus 2 quantity cubed. So clearly these are not equal because we know this equals that, okay? That those are in fact the same. So be very careful, right? I mean, you can FOIL. If you FOIL x plus 2, x plus 2, x plus 2, you multiply it by itself 3 times, you'll in fact get what it is, which is x cubed plus 6x squared plus 12x plus 8, okay? Don't make this mistake of just saying, oh, I'm just gonna distribute that cubed through, you know? Doesn't work. Math doesn't work like that. Don't make up math. All right, let's do our last example. Determine the zeros of p counting multiplicity. So here's our polynomial, 2x cubed minus 5x squared plus 4x minus 1. Okay, now we're dealing with something that's going to have potentially rational zeros because the leading coefficient's 2 in this case. So let's list out the possible rational zeros. We've got 1, -1, a half, and -1/2. That's not so bad. The constant term was 1, so its factors are just 1. And the leading coefficient is 2, so its factors are 1 and 2. So you've got 1 over 1 and 1 over 2. Those are the only things to look at. We'll test them out. We plug 1 in, see if that works. Turns out 1 is a 0. Because if you plug in 1, you get 2, minus 5, plus 4, minus 1. That all cancels out and gives you 0. So that means we're going to long divide it by x minus 1. So let's go ahead and do that. I like this yellow. Let's stay with it. Let's stick with it. So we got x minus 1. It just pops. 2x cubed minus 5x squared plus 4x minus 1. And we'll go ahead and figure out what we need to multiply that by. 2x squared. We have 2x cubed minus 2x squared. Take that away. -5 minus -2. This is -3x squared. So we multiply by -3x minus 3x squared. and my plus 3x. Take that away. We have 4 minus 3, and that's equal to x. X goes into itself one time, so we have x minus 1. Take that away, and that gives us a remainder 0. And so then our polynomial is x minus 1 times 2x squared minus 3x plus 1. So we've factored out x minus 1 after this long division. Now we factor the quadratic that's left. Turns out that this one factors, if you were to set it up, 2x and x. You need the two numbers to multiply to 1. The only way for that to happen and add up to negative 3 is if they're both minus 1 and minus 1. Let's just check that that actually works. 2x times negative 1, that's minus 2x. Negative 1 times x, that's minus x. In fact, those do combine to the middle term. 2x and x multiply to 2x squared, and negative 1 multiply to 1. So we factored it out. X minus 1 times x minus 1 times 2x minus 1. And so we have x minus 1 squared times 2x minus 1. So we have 1 as a root with multiplicity 2, and a half as a root with multiplicity 1. Okay, that is the extent of my examples today. So hopefully that was helpful, that was useful. This kind of approach applies not just for roots with multiplicity, it applies for factoring any higher polynomial. It's just now you know how to handle what happens if there is in fact a repeated root. You just keep going, right? You just long divide it out and factor until it's reduced down to its linear factors. Okay? All right. Well, I'll see you guys in class tomorrow, and I'll have a activity for us to work on, as well as a practice quiz for you guys for the quiz on Friday. So I'll see you guys next time.